Okay, so it's saying that this is in the form of p of x. This is just a continuation of the other lesson. Various points of the graph, find the values of a and b. So how do you think we would do this? You would factor it. Now they've given you some nice stuff here. They said that there's some x-intercepts of that and that. So it's not like we're starting from scratch. A lot of the times, if it's an x to the power 4 or an x to the power 5, they will give you at least one of the factors to get you going, so that it doesn't take you as long. So that means 0 is a factor, so we can go and put 0 in there. Did you know you could put 0 in there? 1, 2, -5, -6, and then, does everybody see there's a 0 for a placeholder? Do you not want to start with 0? But does everybody see it's x to the power 4, x to the power 3, x to the power 2, x to the power 1, and then x to the power 0? There has to be a placeholder right there. Yeah? So 1, 0, 2, 0, -5, 0, -6, 0, 0. So now they also gave you 2 is 1. So then you can factor again. Look at that. You can just bring her down. You don't even have to write it out again. 1, 2, 4, 8. So what's that? 3, 6, and 0. Then what am I left with? X squared plus 4x plus 3, which factors to be x plus what? 1 and x plus 3. So what would that lead you to believe then? That means a is equal to -3 and b is equal to -1. Any questions there? Okay, let's keep going then.
What is that? Wait, how do we...
Next one, we need to find the polynomial function. This is what we just finished doing. These are just a little harder. How would I write a factor that's that? How would I represent -3/2 as a factor? -3/2, put it into a factored form. I'm sorry? 2x plus 3, very good. What about 4/3? What about 4/3? 3x minus 4. Okay, now we have to use this as our points. So -6 equals 8, 3, -4. So 3 times -4 is -12. A. So A equals 6/12, which is a half. Therefore, y equals 1/2 to x plus 3, 3x minus 4. Any questions? Okay. Okay, next one. Does everybody see? We have a y equals a. What's this factor right here represent? X plus 6 to the power 2. Why would it be 1? It's bouncing right there. Okay, what's the next factor? 3x plus 8. Is that to the power 1? Yes, it goes straight through. What's my last factor? 4x minus 9. And is that to the power 1? Okay, so this is a 4th degree. Does that look like a 4th degree? That would be a yes. It's looking like a parabola opening up, which means my a better be positive in the end, right? So -9 equals a 6 squared times 8 times -9. Does everybody see I could divide by -9 to both sides right now? Yes? So 1 equals, what's 36 times 8? I don't have a calculator, remember? 24, So that would be 288, yes? 288a. So a equals 1 over 288. So y equals 1 over 288 x plus 6 squared, 3x plus 8, or x minus 9. Bada bing, bada boom. There we go. So it says here to graph this. Oh, don't you love it when it's all factored for you? Okay, so what's the first thing we're going to do here? Let's do a sign diagram. What goes on my sign diagram? What x-intercept would I get from that? A 2? What would I get over there? -1. Oh, and I need a -3. Shoot, that's okay. Anyways, so let's pick something on the left, a -3. -billion. So what would I get there? Positive. What would I get there? How about negative? And this would be positive no matter what. So negative. So let's pick -2. -2 goes in there. Positive. -2 goes in there. Negative. And this is positive no matter what. So what do I get? A negative. Does that make sense? The sign didn't change there because it's a multiplicity, right? Now we're going to put 0 in there. What do we get here? Positive. Positive. That's positive no matter what, right? And billion. What do we get there? Negative. Positive. Positive no matter what. So we get negative. Okay, so what degree do we have here? It's a 4. Does that make sense? It's going to start down here and end down here? Yes, it's got a negative leading coefficient. Do you see that? Yes. Okay, so now we're going to label everything. So, we need to have a 2. Put a point there. We need to have a -1 and a -3. Does anybody tell me what my y-intercept is? How do I find my y-intercept? I need to find f of 0. So that would be 2 times 1 times 3 squared. Does everybody see it would be 18? So I'm just going to put 18 right there. You can do that because now I'm establishing a scale on the y as 18. Does everybody see that we're going to have negative, negative? So that's going to be like that. At the -1, it's going straight through. At the +2, it's going straight through. Do you see how I'm doing this? It's got to hit the 18 at the same time. So there we go. What do you think? Pretty good? Pretty good? Okay, last one. One of the x-intercepts is x. So this is what I was saying. They help you along by saying one of the x-intercepts x, so you don't have to randomly guess there. So that means I can do synthetic division to find the rest, right? 1 comes down. 1 times 1. 2. 1 times 2. 2, -3, 1 times -3. Then we get a 0. So this represents x squared plus 2x minus 3. And that factors to be x what? X plus 3, x minus 1. Okay? Is everybody good? So what is it? What is this actually factored to be? X plus 3, x minus 1 squared. There's 2 of them. Do you see that? Okay, we're going to do a sign diagram. Well, because it already told me I had 1 and I had an extra one there, right? Okay, so if I pick something on the left of -3, again, this squaring makes it easy. It's positive no matter what. So do you see it's negative? If I take a -2 in there, I get a positive. And if I take a +2, do you see I get a positive? Does that make sense that it's going to look like that? So we're going to do a quick sketch. What's my y-intercept? 3. Very good. 1, 2. Oh, I don't even have to do that. I'm just going to put a 3 on there. 3. Then I'm going to go 1. Then 1, 2, -3. Okay. And remember, it has to go positive, positive, which means it bounces there. It has to go straight through. So do you see how I'm going to do this? It's going to go like that. I don't know. Something goofy like that. Again, it doesn't matter. It could be going higher here for all you. It could go like that, right? It doesn't matter as long as it hits those points. Okay. They like asking this question here. It's a 4th degree polynomial, multiplicity 3, and a 0 up to, at the 0 of 2, and a y-intercept 10. So if this is a multiplicity 3, it flattens. You could have it going the other way. You could have it as, here's a 10 right here, right? Here's a 2, and it could be going like that. It could also be like that as well, as long as it's degree 4.